Hi everybody, my name is Fraser Cain. I'm the publisher of Universe Today, and this is your virtual star party for August 26, 2012. We have got an action-packed star party tonight, and also we'll be doing a bit of a memorial for the passing of Neil Armstrong, of course, the first man to walk on the surface of the moon. So to sort of remember him, we've got some of our telescopes focused on the spot of the moon that Neil and Buzz landed on back in 1969. So joining us, we've got a ton of telescopes too. So I'm really excited. It's going to be a really good night tonight. So right now, this big, beautiful view of the moon is being provided by Cory, who has built. We talked last week about this really great new wedge mount that he built for his Dobsonian, so he's able to track. And as you can see, it is perfectly crisp right now. It's dead set in the middle of his view, so I'm really excited about this. And then the other view of the moon is coming from John Kramer, and look at the level of detail that he's got of these craters. It is just so crisp and clear. It's just an amazing night. And then we were really lucked out. David Riley, who is in England, is bringing us this view of Jupiter. Now, of course, David is about 7-8 hours ahead of me, so it's early morning for him. So he's a total trooper to bring us this view of Jupiter. But it's a really lovely view of Jupiter. You can just see the bands across the planet. The seeing's been a little dodgy for him. He's had some clouds going in front, so. But he'll try and keep that view of Jupiter going for the duration. Now, for most of the people in North America, we haven't seen Jupiter for a couple of months now because it's sort of passed the sun and sort of turned into a morning object. But then as the fall gets deeper, Jupiter and Venus will come back into to be evening objects, and so we'll be able to showcase them a lot better from the next couple of months on. So we've also got. Gary Gonella, who is in California, and he's giving us this wonderful view of the Eagle Nebula, nice and live. And we've got a new participant this week, which is Mike Chasen, who is actually where you're in San Diego, Mike.
Yes.
Yeah. And Mike has got a pretty neat setup. He's got a telescope, telescope he's running remotely from a sort of a dark sky park out of San Diego, and so he's controlling the telescope remotely, and bringing us these images. So right now he's got it focused on the Great Globular Cluster in Hercules, aka M13, and then we've got Stuart Forman, who is in the San Francisco area, and he is showing us the Dumbbell Nebula with his telescope. So look at this: 1, 2, 3, 4, 5, 6 telescopes. Amazing. And then for color commentary, we've got Amy Shira Teitel, who is our resident sort of space historian, and we thought was the perfect person to bring along to talk about Neil Armstrong. What have you got there, Amy?
This is my teeny tiny lunar module from my Space Explorers set.
Is that's behind you?
The big one's behind me. Yeah.
Oh, okay. You might want to grab the bigger one.
Okay.
We got Scott Lewis, provide some more color commentary, and we've got Thad Szabo, who joined us last week. So, hey Thad, who has an encyclopedic knowledge of craters on the moon. Quick, Thad, what are we looking at here? What's that?
The border between Mare Trincolatatis and Mare Serenitatis. Let's see, or is it? Hang on, or
maybe check him on that. I don't know if I can trust him, but anyway, so it's great. It's great to have you. Now we were kind of joking about this beforehand. Part of what we wanted to do was commemorate Neil Armstrong and sort of what a deep and meaningful impact the Apollo space program and has had to all of us. And yet I think none of us were born except for Gary. I'm not sure. I guess you. I was born in '71, so I was born 2 years after the landing. Stuart, I guess you were born, right?
Yeah, I don't remember 11. I remember 17, but not 11.
Yeah. So it's kind of strange, but for me it was like. While Neil Armstrong was alive, it was still kind of recent memory, that this was the time that we're still putting humans on the moon. it's not, it wasn't too long ago, but now it's almost, it feels a bit like it's turned a corner now, that now it's something that's in the past, and we don't really go to the moon anymore. Now I know Buzz Aldrin is still doing fine, and punching people out who think the moon landings were a conspiracy, but still, I don't know. I don't know how other people were feeling, but when I heard the news, I mean, I was sad, but also, I mean, talk about living an amazing life, but it was weird. It really felt like one whole chapter in human space exploration had closed, and now we're moving on to the next one. So we'd love to hear your questions and comments. Oh, yeah, what's that, Gary?
Yeah, okay. I want to make sure I had audio. I was 19 at the time, so I remember it very well. And it was a feeling like no other, just of pride and, look at what we can do.
You were saying that you were actually you weren't actually watching it on TV though, right? You were listening to it on the radio?
Yeah, at the actual time of the touchdown, I was in Central California driving. But
wow.
So yeah, I remember that very clearly. Hearing what they're talking about, but I got to see the video once I got home.
And so, Amy, you were saying that you found out about his passing in a kind of strange way, right?
In a very strange way. I was at the gym yesterday, and I got home and I saw a text message saying "sad about Armstrong," and I didn't really know what that meant. I sort of had an idea. I knew that he obviously had heart surgery, but I didn't know what had happened. I thought maybe he was in critical care. And I see that I have 9 missed calls from an unknown number. And then the unknown number calls me again, and it's the BBC wanting me to comment as an American historian on the passing of Neil Armstrong. And that's how I had the news confirmed. And I went live on the radio and did not speak well at all because I had no time to gather my thoughts or process that. And I mean, I'm obviously too young to have seen it, but I read about Neil Armstrong when I was 6. And have been studying Apollo and everything around it since. So it felt like a big loss. I mean, I've never met him. He looked at 2 of my papers that I wrote about him once, actually. I wrote 2 articles for the Ohio Historical Society about Armstrong as a pilot and as an engineer, and he read them and gave me notes, which was
really?
a little bit scary, but kind of awesome.
That is awesome.
He had nothing to say about how I presented his life, which I thought was good because that meant that I wasn't being, taking too many artistic liberties. All he commented on was very, very particular technical details about how I described how the X-15 flew. And it was very funny because these articles were about his piloting and engineering expertise, and here he is being very nitpicky about the piloting and the engineering behind these programs I was talking about. So that was kind of neat. He's read my work about him. That was nice.
So the view that we've got up right now, this is the one that's coming from Cory, and you can see it's kind of jiggling around because this is live, but this is actually the landing site. So I'm not sure where. Maybe Thad, you might have, because it's flipped upside down. So don't let the orientation fool you, because I know with his Dobsonian he's got it flipped upside down.
Right, let's see. So there should be, I'm looking at an image that I shot of the moon earlier for reference of what's familiar here. So let's see. Actually, I think what he's closer to is Apollo 17 landing site there, because I mean, yeah, that's definitely the border between the Sea of Tranquility and the Sea of Serenity, and that's Apollo 17, I believe, was at the more northern end of the Sea of Tranquility here. So if we scrolled south a little bit, there's kind of a ragged edge and a very couple of bright craters bordering that ragged edge of the Sea of Tranquility, maybe just a little bit to the south.
Okay, let me try that.
Okay. I know he had such a great, nice, stable shot, and I'm like, oh wait, it's a little bit to the one side, but yeah. This is another thing that my students keep marking on their maps, and I'm just like, no, you could not see that through the telescope. I'm glad you've marked it and you recognize that's where it is, but you should be sketching things that you can see. So.
Now we're going to do a regular virtual star party today as well. So now, if you want to give us any comments, questions, or feedback, there's a bunch of different places that you can do it. We'll try and watch all the spots. The one place is if you're watching this on the event page, we'll see the comments there. You can also, if you're watching this on Google+, you can post any comments and questions on the Google+ page. And if you're watching this on YouTube, you can make your comments in YouTube. If you're somehow watching this embedded in some location, you can use Twitter with the hashtag StarParty, and we should see all of these all at the same time. And I will try to sort of, we'll be glad to answer questions, glad to sort of, we will quote the things you say about Neil Armstrong, and we'll also take requests if you want to see some interesting objects as well. So it's great to have everybody watching with us.
Howard just mentioned in the event page that he was 32 and watched the landing on television with his wife and 2 boys, and immediately went outside and looked at the moon together, which is, he said, very moving. And absolutely, how couldn't you look at the moon? It monumentally changed from a human perspective, from not having a human on it to being a place where we've been. That's amazing. It's absolutely amazing, and it's something that's, I know for me yesterday was quite emotional. Obviously, I'm too young to have witnessed it, but just knowing that someone, the first person to have done something so monumental for humanity is no longer with us. It shows a passage and a passing of time, and almost a handing of the torch to a new type of exploration, and hopefully we can maintain that momentum.
Just as a thought, I remember when we didn't know what the dark side of the moon looked like.
the far side, yeah.
Yeah.
That's crazy.
Didn't know.
Paul Gracie says he's in his backyard winking at the moon, looking through my telescope at the same time. I was 27 when Neil said his famous words. Yeah, no, people wondering, this is an absolutely live view of the moon. You can see Cory is moving it around right now. John has a much more stable view.
Yeah, Cory, I think it's...
Let's go through some of the other wonderful objects that we've got here queued up, so people can keep moving. So let's start with Gary. So Gary, what have we got?
Okay, this is the Eagle Nebula, and I'm zoomed in on the center section, which is the famous pillars of creation right here. So you can see the 2 pillars. The famous Hubble photo covers about that much of the area. This is 60-second exposure. Again, done in hydrogen alpha light. I'll zoom out a little bit and we'll be able to see the whole nebula. That gives you the view of the entire thing. You know what? I was moving my mouse on the wrong place when I was pointing that out. All of this over here is because of the moon. It's very close to me right now, but I'm not set up to take pictures of the moon. Once again, since I had the mouse on my local screen and not the right screen, this area right here is the pillars of creation.
Yeah. And so Thad, you think Cory has it? Oh, he's moved more.
Oh, it's still in there.
Okay.
Yeah.
Oh, no, okay. Not anymore.
All right. There we are.
All right. So where are we looking?
Right, that bright crater, right?
Yeah. So the bright crater right near the center there, that's off the southern edge of the Sea of Tranquility. And actually, not that we'd be able to get them with the telescopes that we have in the hangout here, but there are 3 craters near that edge of the sea that are named after Armstrong, Aldrin, and Collins. So, but yep, that's it. That's where they were.
And so that really bright crater there is your sort of guidepost, because it's like a fairly fresh impact, relatively speaking.
Should be. I mean, that's how we're going to get to expose. Well, I mean, it's not really exposing newer material. It's the impact changes the structure of the rock so that it's much brighter, as opposed to the lava plains which make up the Maria, which are a good 3 billion years old. So, yeah, anytime you're seeing a brighter spot like that, it's more newly impacted material. It hasn't undergone the kind of damage from gamma rays and X-rays that could cause it to, X-rays more so, that could cause it to darken. So.
And so, Mike, this is your first time joining us, and you've got something new for us. What have you got?
That I do. Well, long-time listener, first-time caller. Happy to be here. Pulled up a M20. This is Trifle Nebula. It is 4 20-second exposures through red, green, blue, and a clear filter. Then a real quick align stack, and then moving it off of the observatory computer, as you talked about. This is from an observatory about 70 miles from where I'm sitting. Move it over to this computer and upload it, and there it is.
And I can try and give people some context, but it's just above the constellation of Sagittarius.
Yeah, so very close to the center of the Milky Way. That teapot pouring out its steam. That's why there's so many stars, even in just about 80 seconds worth of exposures. So many stars. Such a neat area to shoot in.
Now, is it Trifid or Trifid? How do we describe it?
I'm going to stay quiet here and let the experts talk.
And what is it, Thad? What would you say it is? So, here we go. We got Scott showing us where to find it.
This is definitely just one of my favorite objects. I remember as a kid, it was like, wow, look at all the color and all the detail in this. So the red that we're seeing is hydrogen that is having the electrons excited by an extremely hot new young star that's got to be buried in that nebula somewhere. And so that causes the electrons to jump up to higher energy levels. As they fall, they emit that characteristic red light. There's dark molecular nebulae that cause that trisection of the nebula. And here's where I run into a bit of embarrassment, because I don't get pronunciations of things, because most of my my knowledge of this comes from reading. I've always thought it was Trifid, but I imagine Trifid would work.
I always think Day
well.
of the Trifids, right?
Okay. But essentially it's this dark, cold molecular material that's in front that gives it that kind of trisected appearance. And then off to the one side is that blue glow. And so what this is essentially the same reason that the sky is blue. You have light from these stars that is coming through dust off to the one side from the nebula, and it gets scattered in all directions. And blue is preferably scattered. Blue has a higher frequency than red light. Higher frequency light scatters more. Thus, when sunlight pours into our atmosphere, the blue goes everywhere. So everywhere you look in the sky during the daytime, you see blue. At sunrise and sunset, you're getting the longer wavelengths, the lower frequencies coming straight through at you, so it gives the sky and the sun this reddish, orangish appearance. So the red and orange, or not, you don't really see orange, but the red you're seeing is from hydrogen. The blue is coming from scattered light. That's kind of, so the light from the star kind of comes in this way and then scatters out in all directions. And so as it scatters out, then you get this blue glow to it's called the reflection nebula, adjacent to the Trifid there.
Now I'm going to switch over to what Stuart's got, but we got one question from, I think it's on Google+, which is, how much does a good telescope for tracking the moon cost? It gives a digital output, and what do you recommend? So I guess, what Heath Naylor is asking is, what would it take to be able to get the kind of telescope that could showcase the moon and actually output it and, record video or record images of it?
Any telescope could do that. What's actually more important than the telescope is the mount, because you can. The mount is what tracks. It's not the telescope, and depending on the size of the telescope you're doing, you can put. There's various sizes of mounts that you can get, but pretty much anything will see the moon. It just in terms of tracking the moon, you don't really need to track it that closely, because the moon is so big, and you can take pretty short images of it. But if you want to get into more deep sky stuff, then you do need a mount that tracks reasonably well.
Yeah, the moon's pretty bright, so you don't need to capture it for a long time. I know. I'm trying to think what some of the telescopes are. I would say, like a Meade or a low-end Celestron, something in the kind of $300 range with a go-to mount, something that will actually track, should do the trick. Then for the actual capturing part, if you've got a DSLR like a Canon, that'll do a good job. If you've got some kind of Yeah, I'd probably go with a DSLR. A lot of people also are finding that if they've got a DSLR and they've got like a really good telephoto lens on it, that actually gives you a really nice view of the moon too.
And you don't even have to go quite as high end as a DSLR. If you have a webcam, there are webcams where there are articles online about how to kludge something together that will fit into the eyepiece holder. And basically just have to do some surgery on the webcam. It used to be that old film canisters, like 35 millimeter film canisters, worked really well for this. Not that those are that common anymore. But essentially, the size of the eyepiece holder is 1 1/4 inches. So you just need something that has an outer diameter of 1 1/4 inches. Duct tape it. Super glue it to your webcam. Probably pop. There's a lens, or typically maybe even an IR filter in webcams that you could get. So you do some surgery, take that out of there, use the telescope itself as the lens, and then you can get some pretty decent lunar images, even without tracking. I mean, even if you have,
you don't need to track really.
Yeah.
It's so bright that you just take a quick picture, take a snapshot, and you'll get a good view of the moon.
Right, and I mean, there's plenty of freeware out there where. You could run just your webcam, or if your webcam came with a program, just run it straight through that. And then there are also free programs like Registax, AutoStacker, I guess is another one that's out there. Not Deep Sky Stacker wouldn't work for this, but AVI Stack is another one I found that I really like for planets. And any of these, if you take a movie that you take with your web camera, you can run it through there and really start to bring out some incredible level of detail in your astro images.
And Stuart, you've actually got a really nice image here that you just took. So what is this?
This is the Eastern Veil Nebula, and the Veil Nebula is. I'll let Thad talk about how it was formed, but there's two sides of it. This is the eastern side, and there's also the western side that's a little more stretched out and hard to capture on a smaller CCD chip.
And it looks really nice, Stuart. You're doing like a different trick this week?
I am. I went and actually took away the blacks and adjusted the color balance before I converted it to JPEG to move it over. So
right.
it's
you did a little bit of
yeah. I'm doing the chasing technique.
Right.
Thank you. I wish I could take credit for it.
And now, and Mike, have you got something else that you're going to go for? Like maybe M31?
I've just started shooting on M101, but I've opened to other suggestions.
M101 would be great.
Okay.
Yeah. I'd love to see Andromeda though. We saw it first time last week, and it would be great to sort of see how it's improving each week. So
I think I can get you a part of it. So maybe I can get you the core and that other galaxy. What is it? M110.
Yeah. Oh, Gary, what's this? This looks new to me.
Yeah, well, since Stuart did I think he said the eastern side of the veil, this is the other side of it. So this would be the western side of the veil. So this is a huge structure in space. And if you look at Stuart's, the length that he's showing, if you kind of stood it on in.
Oh, I'll get it back 1 sec.
If you look at the curve, that gives you an idea of how big this circle is. And there's several pieces.
Here it is.
Right.
Now, Stuart, we just had a request for Alcor and Mizar. Do you think you could pull that up next?
No, it's a little too low. I've got a couple other doubles for you though. That's in queue. So
sure, that'd be great. The doubles are such a treat. Yeah.
And sorry. Go ahead.
Go ahead, Thad. I'm sorry.
Just regarding the veil, I mean, what we see in visible light, using visible light, is such a small portion of what's actually going on there. So this is a star that had at least 8 times the mass of the Sun and blew up quite violently as a supernova when it ended its life. And so it's places where there's a fairly large concentration of matter that absorbs the energy from this and re-radiates it as visible light. And so this tends to look kind of wispy. Only certain portions of the region around it will be illuminated this way. They tend to be fairly asymmetrical. But I want to screen share a picture of the veil in X-ray here. And so what you'll see is that it's actually rather closer to spherical in distribution. I mean, it's lumpy on the edges or so, but this expansion of material away from where the star exploded is still mostly spherical. The red in this region is what shows up as visible light. This is a picture taken using X-rays, but to show the full structure. We only see a little bit of the very edges of it when we look using our telescopes and our eyes that are limited to visible light here. So,
but to give the sort of layman's explanation here, it went kaboom, and we're seeing shrapnel sort of spreading. I mean, it's close, right? I mean, it's a relatively close supernova explosion, and so we're seeing just the shrapnel circle expand, just like when the Death Star blew up.
Well, without the added effect that Lucas wanted back and put in with the ring coming out of the middle.
That
just doesn't.
This is just a big shrapnel explosion. Right.
I mean,
it was a relatively close supernova, and this is sort of one of the neat things about it.
Since you brought up the Death Star, just for the record, Han did fire first.
Okay.
And I'm mad at Lucas about that.
So we got a couple of requests. Someone wants to see M33. Where's M33 right now?
That one's too low for me. It's just clearing the eastern horizon.
Yeah. Let's see where it is.
Much better placed in October or November for.
It's really low. So M31 Andromeda is just barely visible right now, and so the Triangulum Galaxy is even below that. So. Yeah.
But stay tuned. We'll have it in an upcoming virtual star party in about a month or two then. So.
Yeah, absolutely. I mean, this is the trick. I mean, people keep asking for the Orion Nebula right now, but I mean, it was the Orion Nebula show all through December and January, right? So, can't wait to get back with our new techniques. What will we see in the Orion Nebula once we get to that point? There we go.
I have the Crescent Nebula now up.
And you're really picking up some of that extra hydrogen gas that's in the background. I mean, this is gas that's been ejected from what's called a Wolf-Rayet star. So the typical classification of stars stops with stars that have a surface temperature of about 40,000 Celsius. Wolf-Rayets are even hotter than that. They're extremely massive stars, and the thing is, the more massive a star is, the more gas it will eject throughout its life. So it will billow gas away from its outer layers. Here from the sun, we have the solar wind. Think of this as the solar wind turned up to like a hurricane force. And so it's blowing away from the star, and so you get this kind of poof around the star in this crescent shape that's also being illuminated by the just crazy amount of radiation coming from the star itself. That thing, when it goes, it hasn't gone supernova yet. That's the thing. I guess we don't know, because if it has, it's a few thousand light years away. Maybe it did, and we haven't seen the light from it yet. But when it does, that'll be spectacular. The Northern Cross Cygnus the Swan will have an extra star right next to the middle of it when it does. So.
Those Wolf-Rayet stars, none of them are going to be living very long. So I mean. Mm-hmm. Yeah, they're all within a couple of million years from going kaboom.
Right. For a star, of course, if we say not living very long, well, I mean, for us, 100 years, it's gone like that astronomically. So,
yeah. All right, so Thad, it's quiz time here.
Okay.
What's that?
What's which one?
So I've switched to John Kramer's view of the moon right now, and that's right, you can't see. So you're going to want to click on John Kramer's view, the one with the that big crater there.
Okay.
It's
Copernicus.
That's Copernicus.
That is Copernicus. So
look at that. Look at how crisp his view is. This is just astonishing, John. This is such a nice view of the moon.
Thank you, Fraser.
Yeah, I think this is probably the crispest, clearest, sort of most stable view of the moon we've had in one of these star parties. So I can't wait to get to see some of your planetary stuff once they move back into view.
I had some nice shots of Jupiter just early this morning at 4 a.m.
Perfect. Well,
feel
free to show them off at some point if you want. It'd be great to see them. Well, I'm going to go back. Okay, so David can neither hear us nor talk to us. So he's the one in Europe right now, and as I said, because he's in the far future compared to the rest of us, he's seeing what the Earth will be seeing from our perspective in another 6-8 hours. So so this is Venus, which is pretty neat, and I think people might be quite surprised to see how Venus looks like a crescent. In this case, it's like a half moon, actually, is what it looks like. Andrew Clark just asked, is this pic live on the planet? Yes, this is a live view of Venus seen from England right now.
That's awesome.
Yeah. That's why it's jumping around. That's how you know we're being legit, is when you see the pictures, when it's jumping around, like the image of the moon, right? The image of Venus, and, well, John is just, I don't know how he's doing this. But I promise it's not. His is live as well. Oh no, we're getting some clouds in front of David's image, but
yeah, that kind of jumping around you're seeing, that's not the planet itself. The planet is going kind of rock steady in its orbit, going along at a velocity higher than Earth because it is closer to the sun than the Earth. But the Earth's atmosphere acts like a lens, and so the thing is, it's not a neat lens like you would have in a telescope that always produces the same image. As there are changes in temperature, slight changes in pressure, it's kind of like looking over a barbecue grill. So if you've ever been out barbecuing and you're trying to look over top of it to see somebody, they're kind of waving in the background there. Well, here, that little bit of waving in the atmosphere, small temperature changes, are extremely magnified. And so when you're looking at Venus, you never are looking very high above the horizon, so you're also looking through a very thick portion of the atmosphere to see it. So there's a lot of waving going on, and that's why Venus looks like it's just kind of swimming around and changing shape a little bit, and I guess that's a cloud. Right? So, but that's an effect of having an atmosphere. So, if we had space telescopes that we were doing this from, then you wouldn't see any swimming. Also, no clouds either then. But but yeah, that's the only reason that you're seeing this kind of. Well, why can't you get it to sit still? Well, if we could pump the atmosphere off the Earth, sure, it would sit perfectly still, and everything that we're doing here would be over very quickly also. So. Well,
and what's interesting, this is the way these adaptive optics telescopes work, right? They shoot a laser beam up into the sky. They create a virtual star in the sky that they know how it's supposed to be behaving, and then they watch how this star that they're projecting into the sky is waving around in the sky, and then they take the telescope and they have pistons behind the telescope that push the mirror up and down to warp the mirror to counteract the distortions that you're seeing in the atmosphere. And so it's a way that these amazing adaptive optics systems can adapt to the how the atmosphere is changing like this. And so if you had a really nice adaptive optics system viewing the Venus, it would be look a lot steadier, even though the atmosphere is still very chaotic.
Right. And the other thing, just for something people might have a little more familiarity with, if you've ever used noise-canceling headphones. So there's a microphone on noise-canceling headphones that samples the outside. So you're on the airplane and you have the whir of the jet engine, whatever else, and if you have noise-canceling headphones, it puts through a signal along with what you're trying to listen to that directly cancels the signal from the outside. So all you hear is your music or whatever book you're listening to on whatever device. Adaptive optics is the same thing except for light. So we look at what the atmosphere is doing. We have, like you said, the pistons on the back of the mirror adjust the shape of the mirror and cancel out what our atmosphere would do. So same principle.
Fantastic. I hope David can hear me because it's just fantastic. That's a beautiful view of Venus. I'm really, yeah. Well, David is asking if he should go back to Jupiter. Sure, why don't we go back to Jupiter? It's going to tell him. So David will go back to Jupiter now. That is fantastic, though. Wow. So Gary, Andromeda.
Yes, it is.
Nice.
And as you said, as the year progresses, to get this, I'm pretty low to the horizon. This is the position of my scope. So you can see how it's pretty low in the sky. Another 2-3 months, it'll be almost overhead and much better view of it. but it was requested, so here it is.
And you can't get anything below that, right? You couldn't get M33.
I don't think so. Let me take a look. I think it's going to be too low.
Yeah, I'm sure.
M33 is a good 10 degrees lower.
Yeah.
Yeah.
I'm going to move on to what Mike's got. M101, right?
There it is. Yeah, this is 4 1-minute shots. It's a little bit low in the west, so I had to darken down the background a little bit just to show the galaxy, but still not too bad for 4 minutes worth of exposures. One of my favorite parts is another, I believe it's a small galaxy. It's up high to the right. You can barely see it. It looks like a smear, but it is there.
Up to the right.
Let me see if I can find that. I keep pointing to my monitor, but I guess no one can see that. It's barely showing up. It looks like just a star. But I think there's several other galaxies within that field. I don't know if, Scott, you have that pulled up with your view. But it's one of the things I always like to do when I take a picture. It's fun to look at what you took the picture of, but then it's also a lot of fun to see how many faint fuzzies you can pick out in the background, which I guess, since they're so small, is other galaxies far, far away in the distance.
Now, Gary, we had a request for the North America Nebula. Is that still in view for you?
Yes. I can give pieces of it. Yeah. I don't even have a wide enough view to give the whole thing. Okay, I'll put that on my list here.
Sure, that would be great. The M101 is fantastic. I mean, this is a great example of a galaxy that we're really seeing face on, and so we can really look right down and see that spiral structure. Now, just for people to understand here, now in your case, Mike, how long of an exposure is this?
Those are 1-minute exposures, each shot through a red, a green, a blue, and then a clear filter. So it's a total of 4 minutes worth of exposure time. So not much. Normally, if I was going to shoot this to make a pretty picture to put on the wall, I would probably take, I don't know, a dozen or so subs about 10 minutes long through each filter. So it would be hours and hours worth. But just being able to see it in that short amount of time just absolutely amazes me.
That is amazing.
Yeah, absolutely fantastic. Well, you're welcome back anytime, Mike.
Thanks.
Well, you've got some amazing skies down there.
Yeah.
At Tierra del Sol, it's just.
Well,
that's where I was for the Venus transit.
That's right.
Daytime, but for the nighttime, we had a little bit of time to do some observing the night before the fog rolled in, the fog of doom. It was kind of creepy, but no, you guys have some amazing skies down there.
Thank you. Yeah, I have it's called an all-sky cam. If I can give a plug for a website, I think it's allskycam.com. And this website shows you the folks who have these cameras installed outside. They're all around the world. So you can see mine out in Tierra del Sol in San Diego. You can see what the skies look like up in Alaska, to the Middle East, to the Far East. It's kind of fun to just take a quick lap around the world and see what the weather looks like.
Yeah. Now, we had a request for NGC 7009, which is also known as the Saturn Nebula, and it's sort of in between Aquarius and Capricornus. So, have we done that one before, Gary?
I'm sorry, I was moving. Which one?
The Saturn Nebula. Have we done that one?
No, it's extremely small.
Yeah, it'd be better for somebody with a planetary kind of camera, because one thing I guess that may not come across to people who are viewing is that when you look across the bottom at the views here, I mean, we've got the Moon, Jupiter, it looks like a planetary nebula, then the Moon again, then M101. These are radically different size portions of the sky. When we were looking at the Moon, you could kind of tell if you went outside about how big that is. But to give a feel for it, to kind of put these together, the portion of the Moon that you're looking at is basically if you took the picture of Jupiter and put 5 Jupiters next to each other. So that one's bigger than the field of view of Jupiter. The other field of view of the Moon, about the same size. When we're talking about the planetary nebula, then you're talking something on the order of maybe 40 or 50 Jupiters from one side of that field of view to the other. When you're talking about the view of the galaxy M101, that's about 60 Jupiters from one side of the field of view to the other. So very large difference in the sizes of the portion of the sky that we're imaging. So if you're asking for the North America Nebula, that's essentially 180 Jupiters from one side to the other to be able to see the whole thing. It is positively an enormous region of the sky. It would take about 36 full moons to cover the region of the sky covered by the North America Nebula. So.
Yeah, we've mentioned that this is Gary's life work, that he's planning to take really nice pictures of the North American Nebula and stitch them all together into one great big picture. And it, lining up all those images, it really is going to keep him busy for a while.
That it will.
So Matt1888A mentions on YouTube that once Google Plus Hangouts are streamed in 1080p, this is going to be even more amazing. So this is the thing. So for those of us who are actually in the Hangout, we actually do see the 1080p resolution. And unfortunately, the people who are watching outside of the Hangout only see the 480 version.
I'm getting it in 1080p, actually.
1080p, 4K, yeah. Beautiful. But yeah, no, it would be great. I can't wait, if Google Plus, the Hangouts can make it to full high def, that'll be wonderful. I promise we've got really great views here. So Amy, you're going to duck out for a second, and we're gonna replace you with Emily Lakdawalla.
Yes, I know she's waiting, so I figure I'll hop out for a little bit and just I'll be watching.
Thanks for bringing the history, Amy, and you want to see a lot
since
more
I built this, I'm going to show it off for a second here. This is 1/48 scale lunar module. It's from the Buzz Aldrin Rocket Hero collection. It says it on the box.
and before you do go, Amy, where can people read your recent article about Neil Armstrong?
I was just going to link it actually into the event page, but go for it.
Scott. You can find, I posted one on my blog and one an op-ed in the Guardian. You can find both of them on my blog, which you can find at amyshiratitle.com, or if you Google vintage space, I come up first now, so that's fun.
Right.
So Google that, and you can find my stuff, and Google Plus.
Perfect.
Kind of where I am. So.
And and Amy's one of the regular participants in our weekly space hangout. So we'll see you again in a couple of weeks once we get that all rolling again.
Looking forward to getting back to that. So.
All right.
Yeah, may see you guys later.
Amy.
Bye.
Thank you, Amy.
Thanks, Amy.
And
thanks, Amy.
I will send the invite to Emily. And Emily Lakdawalla is from the Planetary Society. And always a treat to have joining us. There's the Jupiter. Man, that's fantastic.
Yeah, you can even see some details, some split in the one equatorial belt, that it's not all the same color. So that's yeah, that is really nice.
There we go. There's Emily.
Hey, Emily.
Hi,
Hi
Emily.
there.
Hey, Emily.
Hey, everybody.
Sorry, we didn't have room for you. We have like 7 telescopes going, or 6.
That's pretty amazing.
It really is. Yeah, yeah. I think this is one of the sort of best nights that we've had. So I can't even keep up with the images. In fact, I'm gonna quickly run through it before we get back to you, Emily, so that people can move on to other things. So Gary, what's this?
This is one we have not imaged in the Hangout. This is the Cocoon Nebula, IC 5146.
I like it. It looks like a heart to me.
Kind of does.
Yeah. But like not like an actual heart, like an anatomical heart, not a Valentine's heart.
Yeah. And I can see. I'm going to take a second to refocus. We've had such temperature change between day and night. If you look at the stars, you can see. Let me see if I can get it open enough. There we go. See, some of these have a little hole in the middle. I've drifted out of focus. So I'll focus it, and then I'll move over to the North America and see what pieces I can get of that.
Sure, that'd be great.
Okay.
Mike's still got M101. And Stuart, you've got a double star for us. I don't know if Stuart can hear us.
So yeah, he's Albareo, definitely.
Is it?
Yeah.
Because someone wanted to see Alcor and Mizar, but I know it's too low for him. So Alcor and Mizar is in the Big Dipper, but this is another one, right?
Right. This is at the head of Cygnus the Swan, or if you view it as the Northern Cross, it's the foot, the
Sorry,
star
I'm
at the bottom of the.
Yeah, I'm back. Yeah, sorry. So
did Thad guess right?
This is Alberio. He is correct. Yeah, I had a gentleman walk by and he was looking at my computer, so I was talking to him. Yeah. So yeah, this is Alberio, and I'm gonna get Epsilon Lyra in a second. I've got a bunch of stuff queued up, so but I'm sort of waiting for it to come around.
So John just mentioned he's got Plato in view right now. This is the crater Plato on the moon. But John, you're going to share an image. We're going to break one of my rules. But that's okay because you got such a beautiful live view. So John is going to bring in a view of Jupiter that he captured this morning. So that's all right. We'll permit it this one.
All right, give me a couple minutes. I'll bring that up.
Okay, great. Thanks. So Emily, how have you been busy in the last couple of days dealing with the passing of Neil Armstrong and all of the I guess it was yesterday, right?
Well, you have to remember that I have a 3-year-old and a 6-year-old, so I've mostly been busy in the past couple of days with them. But I tried to do what I could by inviting Planetary Society members to talk about how Neil Armstrong influenced their lives, because I was born after the moon landings, so it didn't really have the resonance for me personally that it has for a lot of our members. But since working for the Planetary Society, I've come to understand just how important an event the moon landing was for people who are really enthusiastic about space. So even though for me it doesn't have that same kind of resonance, I understand that for the people who read what I do and who care about what the Planetary Society does, it's really important, and this is a really crucial moment for them.
Yeah. And so I've gone back to Cory's view here of the moon. So this is again that bright crater right down in the middle, right down near the bottom. That's about where the Apollo 11 landing site was.
Right, just a little bit to from the view that's through the telescope here, a little bit to the left, and down a little bit. I mean, that kind of sounds like almost Armstrong's read back when he was landing. This many downrange, this many left, this many. So, and just an incredible bit of flying to actually get that landing. I mean, what is it? He only had 30 seconds of fuel left to land on the moon. Below that, they wouldn't have had enough in reserves to get back up to meet with the command module. Is that correct?
I think he landed with 17 seconds, if I remember correctly.
Yeah, that takes some guts.
Well, and he's known for having some gutsy moves as a pilot as well. I mean, with doing some of his test flights and things like that, landing with I think around 100 feet to some Joshua trees. He almost overshot the landing. He likes to push the limits, and he definitely did. And he had the guts to do a lot of amazing things, obviously, for getting onto the moon. But even before NASA, he was an amazing pilot, and he did some amazing things.
So here's John's image. Can you talk to us about this image, John?
Sure. This was taken with the same setup, only using a Barlow lens. So this is a C8 with the Samsung SCB2000 video camera. This is a stack of about 2,500 frames, stacked and then processed in Registacks as of 4:48 a.m. this morning.
Wow.
That is some beautiful detail.
That is great.
So that's the kind of stuff. Now David's mentioned that he's got rain clouds coming in on his view, so it might very well be that we're going to lose him. Now, and David, I don't know if you can hear me, but if you could, I don't know if you've been recording any video while you've been capturing this image of Jupiter, but if you wanted to to post an image. One of the really neat things, actually, for all the astronomers tonight is with the events themselves now, you can post photographs into the event. And actually, if you go back and look at some of the events that we've done, we've had some really neat view. So we've got the event and all the conversations, but also, during the Curiosity landing, I didn't realize this till afterwards, but people were posting pictures into the whole into the event page, and so you actually could see a timeline from some of the earlier screen grabs and things like that, all the way down to the landing, and all the photographs were being posted, and they're all sort of embedded into the event. And I know a few people have been doing that. So that's on the event page on where we actually announce the hangout. And so for any of the astronomers, if you want to sort of join, during the event or even afterwards, if you want to put in some of your pictures, then it's a great way for people to like look through the event and see all the pictures that were taken during the event itself. So it's actually a pretty neat trick. So it's a new way for us to start working, but I think you might want to give that a try. So during either while you're doing the hangout, although it might be too complicated, or even afterwards, post some pictures into the event so people can see them. It's really neat. And feel free,
you're going to have to tell me how to do that again because I was concentrating on something else with an
You got to go. You got to go.
You don't have to tell me now. Just tell me later.
No. Yeah, we'll figure it out. So what's our time right now? I'm trying to think how long we've been at this for. I guess about an hour now.
About an hour now. Yeah, we started a little bit
all right.
late. So.
We'll catch up on a couple of things here.
Gary's
so that's
got
the North American Nebula.
Yep, that is what I got. That is the Gulf of Mexico right here. And this is Mexico, and this is the Florida little piece that comes down. I can show you real quick what that looks like, and the purple box is where my field of view is. So to get the whole thing, I'd need at least a half a dozen pictures to be able to stitch it all together.
So Emily, someone's asking for Bill Nye. And I know that's.
I wish I could give Bill Nye to you right now, but you know what? Pretty soon I really ought to do a hangout with Bill because I'm sure he would be delighted to talk with people. So I will hook that up in the next couple of weeks. Okay.
Like maybe on the Weekly Science Hour or have him
something
join us
like that. I'll figure it out. It kind of
Yeah.
depends on his schedule. He's in town only about half the time because he's got a lot of speaking engagements. So
Yeah, I was listening to his interview on the Nerdist podcast with Chris Hartwick, and that was
a great interview. I was actually
fantastic.
watching that live. Yeah.
I know you were, because he kept referencing you in the room while he was doing the interview, and but it was just a real treat to hear him talk, and it would be fantastic to have him sit here and look through the telescopes with us sometime. So
Yeah.
if you could make that happen, that would be wonderful.
Absolutely.
Yeah.
Actually, I just had a realization looking at Gary's North American Nebula here, that if we're going to continue the analogy of it being representative of North America, that bright star that's kind of in where Texas would be is just about where Houston is. And, we switched off of it.
Sorry.
So it's okay. But, yeah, it looked like there was one star pretty close to where Houston is and then another one pretty close to where New Orleans would be. And, yeah, just... that's one thing we get with these hangouts is you get a lot of time to kind of just stare at one thing and really take in a lot more detail. And so I don't know if anybody's ever really thought of like pinning cities into North America in the nebula there before. But yeah, there they are. So.
This is great. So Scott, you just did that. You just posted an image, a screen grab of the hangout into the event page.
So there's David's Jupiter of what we see in a hangout, and I posted it up in there.
Yeah.
Of what we're able to see, they're all blown up and embiggened.
Yeah.
And yeah, David, you're doing an amazing job over there. I know that you're having some seeing issues, especially with rain clouds coming in, but your Jupiter is beautiful.
Yeah. So again, I mean, I know that people are seeing this about 100 different places. So if you go to the event page where we announce it and where you can, so each week we'll actually announce the event, and then you can go and sign up to be able to know when it's going to be starting. And so if you go to that event page, we're posting a bunch of pictures to it. It's really hard to find all the places. When we start the hangout, it's almost like it just explodes into all these different places. It's on YouTube, it's embedded on different websites and stuff. I know we try to figure out how to bring it all back together again to actually answer your questions. So
someone needs to make an app for that.
Well, there kind of is. There's an extension into the Hangouts on Air called Comment Tracker that lets me track all the places that the comments are being made, but still, it's pretty tough. So, so David just mentions we're going to lose Jupiter in about a minute because it's about to rain. So, enjoy your last fleeting images of Jupiter now.
So if I can just ask some questions about this image of Jupiter, I'm a planetary scientist who does not look through a telescope very often, so that's where my questions are coming from. But this is inverted, right? So south is up, so we're looking at a red band from that has reborn from that band actually disappeared recently last year. And so can you tell me about what it's been doing the last year?
Who?
Anybody.
Oh.
Anybody who looks through a telescope regularly.
I mean, we lost the north. Was it the north or the south equatorial band?
It was the south. South
equatorial band, yeah, for a while there. Oh, it's been a while since I've imaged Jupiter. Again, not sure what the atmospheric dynamics are that's responsible for this. I mean, I think generally, and I'm sure you could add to this, the thinking is that the bands don't actually go away, that it's more that high clouds kind of fill in over where the band is. When we're looking at the bands, we're looking deeper into the atmosphere, and so if higher clouds move in over it for the period of time, that actually obscures the view of the darker, warmer organic, not organic, but more complex molecules that are deeper in the atmosphere. Is that the correct way of thinking of that?
I think it's absolutely correct, and I just I ask you guys about Jupiter because those of us who study the planets through spacecraft, we're kind of chauvinistic about spacecraft, and you get these great images from spacecraft, and you kind of ignore what happens from Earth. But the fact of the matter is that professional planetary scientists absolutely rely on amateur astronomers to follow the dynamics of the atmosphere of these very changeable places like Jupiter and Saturn and even Uranus. Because, without the amateurs constantly monitoring what's happening, we'd never know when the bands disappear or storms blow up and stuff like that. So it's one area of science where amateurs are absolutely crucial to making sure that science goes ahead, because they're the ones who are monitoring what's going on with these great planets.
So Slavomir asks, was that Jupiter live? Yeah, that was a live view of Jupiter, and if you missed it, we had a live view of Venus earlier, which was just great. Now I want to. Mike and Stuart have been very patient and queued up a couple of objects here, so I want to make sure that we get these. So, Mike, what is this?
That is the Pelican Nebula, one of my daughter's favorites. If you are creative, like a young kid would be, you can look at that and within about 2 seconds say, oh, yeah, there's the top of a pelican's head, about the top middle of it, and you can kind of see the eye, a dark spot a little bit off to the right, and then its beak descending off to about the 3 o'clock position. As an adult, I usually look at that, turn my head around 3 or 4 times, and have to ask someone else just what the heck that is and how it got that name. Yeah. But amazingly enough, I have my kids look at that, and within seconds they can find a pelican out of that. So that's
haven't we said it's the looks like a pterodactyl nebula?
I could see that.
Yeah.
See that.
I'd go with that.
It could also be a rabbit with its nose to the right, its eye, and then its ears off to the left.
It's almost like a Rorschach test, isn't it? Like whatever we see in this, we see what we want to see in this nebula.
I think that's Zaphod
I see a
over
dinosaur.
There.
In just a minute, I should have coming up a shot of M110 and a bit of the core of M31.
Well, I'm going to go to what Stuart's got, and I think we know what this is, Stuart. What is it, Stuart?
This is the Ring Nebula, and this is a 60-second shot. It's a little smeary. I'm not entirely happy with it. I don't think I'm super polar aligned. I've had better, but you can make a little bit out of the color, and you can see the star that's behind it, and it's obviously a ring.
Yeah, I don't know if people can see it in outside of the hangout, but I can actually see that central star in your image. Is that like the burnt-out white dwarf star at the center of it? Yeah.
Yeah, Pamela says that it's actually not the burnt-out white dwarf.
I don't think it's the. I think it's just almost something that's been superimposed on there, or actually behind it, or
behind it. Just another star.
What's actually there.
Oh, so Cory's saying that he's got a close-up on the landing site. Oh, there it is. Right. So there's that bright crater again. So Thad, I don't know. Now where are we?
Let's see.
To the left of that bright crater?
So definitely getting some seeing issues. I think I got to get oriented here too. Let me bring
I think he's popped a bigger Barlow on his telescope.
So hang on, I got to bring up my own image.
Yeah, that's a 2x Barlow.
So let's see.
But I see that white crater that we had before, right?
Yeah, I think actually the actual landing site is going to be left, and it would be in the lower left corner of the view that we have right now. So scrolling over a little bit here.
No, not that way.
Okay.
That way, yep.
There we go. Okay. Yeah, so now we're bringing where the landing site would be a little bit more toward the center. So
yeah.
Yep. But again, just an incredible level of detail on getting, being able to get some of the walls of the craters, and again, bright material from newer impacts. The one other thing, it's not going to show up so well with where we're looking at the moon right now, but if somebody who had the moon might be able to get over toward the terminator. The terminator, not being on or anything like that, right? The terminator is being the line between sunrise or daylight and nighttime on the moon, and so you get some very stark shadows along those. So if you really want a feel for just how deep some of these craters are, that's the kind of image that can give you that kind of 3D relief to what you're seeing there.
Yeah,
so,
John's moved over to the Terminator right now. Now this view, this is Scot's simulation through Stellarium, so that's not real. This one's real. This is John's view, and this is the Terminator here.
Right.
Taking it.
So so Copernicus is the big crater off to the right in John's view. Let's see. I'm sure I'm going to get some more of these in moon maps that students make this semester, and we'll have more. I'm having them do that end of September. So if we do another hangout with the moon beginning of October, I'll know these all off the top of my head. Boom,
we don't
just
expect you to be a walking, talking moon atlas, although that would be awesome. So if you want to, that would be fantastic. Well, I think we probably need to wrap this up now. We've been about a little over an hour now, so. So once again, I think this is great. I see Stuart's got one more image here for us.
Yeah, this is the double-double in Lyra, and this is Epsilon Lyra. And if you're going to look at this in a telescope, in binoculars, you would just see this double star right there. But if you look at it under a telescope, each of these double stars will resolve in itself into a double, and I just think it's cute.
That's right. Cool, and so thanks to Cory and John for bringing the moon. I mean, that was I was really nervous that we were going to be able to get a shot of the moon tonight, and we actually got two phenomenal views of the moon. So thanks a lot, guys. I really, really appreciate it. This has been just wonderful. Perfect. And thanks again to Gary with his view of the North American Nebula, and thanks to Mike for his first time. You did great. You are absolutely welcome back anytime, Mike.
Thank you very much. Happy to be here.
No, it was fantastic. I really appreciate it. And thanks to Stuart. And I look forward to your future plans, Stuart, to take a 200-foot cable out of your house and up the hill so that you could be broadcasting from a better view.
Yes, me too.
That is really quite something. I look forward to it. And thanks to Emily for joining us at the last minute, bringing some science, and Scott, my partner in crime. And thanks to Thad for this is your second week, and once again you've been an absolute fount of astronomy knowledge. It's really great to have a professor of physics here at the same time being able to help explain this stuff. So it's great, and
Thanks.
a walking, talking, clearly lunar atlas, which is great.
Absolutely.
All right.
Yeah, you need to be a little faster next time.
Here.
If you can
Good to be
really,
here.
Get the.
Give me flashcards or something.
There you go.
That's a crater. Okay, that's another crater. That's another crater. I don't know. So.
That's another crater. Yeah. Cool. All right. Well, now things are going to get a little weird for the next couple of days. So on Thursday night, we're actually going to be doing a live broadcast from DragonCon, and this is actually it's not going to be a star party. We're going to be doing a live broadcast of a speech from Phil Plait and from Nicole Gallucci, and I think Marion Call is going to be playing some music, and this is from the Atlanta Skeptic Society, and they do a star party every year, just before DragonCon, and so me, Pamela, Phil, Nicole, we're all going to be at DragonCon this year, and so we're going to be broadcasting their talks as a Hangout on Air. So this is sort of a new experiment. So that's going to be on Thursday night. You can just do a search for like Atlanta Star Party, and you should be able to find it.
What time's that going to be, Fraser? Are you going to do
I think
more
we're
or less?
going to get started around 10 p.m. Eastern time, so that's going to be about 7 Pacific, which I know is going to be not quite dark enough for most of the people. So, we'll yeah. But I think I'm not sure what time the actual speeches start. I think a little earlier, actually. I think we're going to probably around 8, so 5 Pacific. Yeah, you can find the information on their website. I'm sure Scott will have already dug it up and pasted it into the event page.
Oh, no pressure. Thanks. The one time I wasn't looking for a link to place up there.
Oh, really? Okay. Usually you're reading my mind, so.
I'll put it up there.
And then, I don't know, I'm going to be at Dragon Con on Sunday night, so Scott, I don't know if you feel like filling in and running a Star Party on Sunday night.
I'll see what we can do.
All
I think
right.
we can rock out some astronomy.
Yeah, that'd be cool.
It's my turn to host the weekly science hangout. I will check to see if I can get Bill, but I don't know what his schedule is going to be. If not, do you think it's time for another Curiosity, just chat with me kind of update, or should I try to find somebody else, do you think?
Sure. Yeah. We could do another one. No, I mean, do you want to do an... you know what? I'm going to be traveling on Wednesday.
I'm game. I can run it, and I have friends, so I can hook that up.
Yeah. Put together a team. And then we'll be starting Astronomy Cast and the Weekly Space Hangout. That's all going to start up again after we get back from Dragon Con. We're going to do a live show at Dragon Con, and then we'll be back. The kids will be at school. We'll have a lot more time on our hands to be able to get back at bringing you all of this space news every week. So thanks again to everybody who joined us here. Thanks to everybody who's watching. It was fantastic, a really great night. And thanks to Neil Armstrong for making us all so inspired in space exploration and astronomy. I can't understate I can't say how much his life and accomplishments means to all of us. So thank you, Neil. All right, see you later, everybody.
Good night.
Good night.
Thanks, everybody. Good night.